So, good afternoon everyone. Welcome to my reaction video. As we can see today, we talk about the difference between microprocessor and microcontroller. So, introduction. A computer is a programmable machine that receives input, stores and manipulates data, information, and provides in useful form. This is diagram of a computer system. As you can see, this is the basic devices, external devices on the computer. And this diagram is a basic computer system. As you can see, the CPU, ROM, RAM, input and output interface, and input-output devices. And here are the address bus, data bus, and control bus. Basic component of microcomputer. CPU, or should we say, central processing unit, the portion of a computer system that carries out instructions of a computer program. The primary element carrying out the computer's function, it is the unit that reads the executed program's instructions. The data in the instruction tells the processor what to do. So this microprocessor is serve as the brain. Memory. Physical devices store data to program sequence of instructions on temporary or permanent basis for use in an electronic digital computer. Computer main memory comes in two principal varieties: random access memory, RAM, and read-only memory, ROM. RAM can be written to anytime the CPU commands it, but ROM is preloaded with data and software that never changes, so the CPU can only read from it. ROM is typically used to store the computer's initial startup instructions. In general, contents of RAM are erased with the power when the power to the computer is turned off, but ROM retain its data indefinitely. In a PC, the ROM contains a specialized program called BIOS that orchestrates loading the computer's operating system from the hard disk drive into RAM whenever the computer is turned on or reset. Input and output unit. Input and output unit refers to communication between information processing system, such as a computer, and the outside world, possibly a human or another information processing system. Inputs are the signals or data received by the system, and outputs are the signals or data sent from it. Devices that provide input or output to the computer are called peripherals. Only a typical personal computer peripherals include input devices like the keyboard and mouse, and input devices such as display and printer. Hard disk drives, floppy disk drives, and optical disk drives serve as both input and output devices. Computer networking is another form of input and output. These are the data sites. The default has 4 bits, the byte has 8 bit, word 16 bit, and the long word is 32 bit. Fetching and execution cycles. Fetching cycles. The fetch cycles takes the instruction required from memory, stores in an instruction registry, moves the program converter on one so that it points to the next instruction. Execute cycle. The actual actions which occur during the execute cycle of an instruction depend on both the instruction itself and the addressing mode of specified to be used to access the data that may be required. Fetching an instruction. Step 1. Instruction pointer, program counter. Hold the address of the next instruction to be fetched. And step 2, step 3, step 4, and step 5. And step 6. Internal structure and basic operation of microprocessor. So ALU register section, address bus, data bus, control and timing section, block diagram of microprocessor. Arithmetic and logic unit, ALU. The component that performs the arithmetic and logic operations, the most important component of microprocessor, is typically the part of the processor that is designed first, able to perform the basic logical operations and or including the additional operation. The inclusion of inverters on the input enables same ALU hardware to perform the subtraction operation, adding an inverted operand, and operations NAND and more. And this is a diagram of structure of ALU. Control unit. Circuitry that controls the flow of information through the processor and coordinates the activities of the other units within it. In a way, it is the brain within the brain, as it controls what happens inside the processor, which in turn controls the rest of the PC. On a regular processor, the control unit performs the tasks of fetching, decoding, managing execution, and then storing results. And this is a diagram of the control unit. Alright. Register sets. The register section array consists completely of circuitry used to temporarily store data or program that codes until they are sent to the ALU or the control section or to a memory. The number of registers are different for any particular CPU, and the more registers a CPU will result in easier programming tasks. Registers are normally measured by the number of bits they can hold, for example, an 8-bit register or 32-bit register. Accumulator. A register in which intermediate arithmetic and logic results are stored. Example for accumulator use is summing a list of numbers. Accumulator is initially set to 0, then each number in turn is added to the value in the accumulator. Only when all numbers have been added in the result held in the accumulator written to main memory or to another non-accumulator CPU register. Condition code register. An 8-bit register used to store the status of CPU such as carry, 0, overflow, and half carry. So this is the flag name and description. Z, 0 flag, indicate the result of a mathematical or logical operation was 0. C, carry flag, indicates the result of the operation produced an answer greater than the number of available bits. This flag may also be set before a mathematical operation as extra operand to certain instructions. Add with carry. Extend flag. Must the circ request when set, it is set by the hardware and cleared by the software, as well as set as an unmaskable circ. I don't know what that is. Negative or sign flag indicates that the result of a mathematical operation is negative in some processor, and the N and the S flags have different meanings. The S flag that indicates whether a subtraction or addition that has taken place, whereas the N flag indicates whether the last operation result is positive or negative. The B, overflow flag, indicates that the result of an operation has overflowed according to the CPU's word representation, similar to the carry flag but for sign operations. I, interrupts. Interrupts can be enabled or disabled respectively, setting or clearing this flag. Modifying the flag may be restricted to programs executing in supervisor mode. So the program counter, or PC. A 16-bit register used to store the next address of the operation code to fetch by the CPU. Not much in use in programming, but as indicator to user only. Purpose of PC and the microprocessors to store the address of a toast or top of a stack, to store address of next instruction to be executed, count the number of instructions, to store the base address of the stack. So these are the structure of PC. Stack pointer. The stack is configured as data structure that grows downward from high memory to low memory. At any given time, the SP holds a 16-bit address to the next free location in the stack. The stack acts like another stack. There is a subroutine call or an interrupt, i.e., pushing the address on a jump, retrieving it after the operation is completely to back of its original location. The bus system. Bus system that transfer data between computer components inside a computer or computers. So this is the 4 PCI Express bus card slots from top to bottom. Times 4 times 16 times 1 times 16 compared to the traditional 32-bit PCI bus card slot. Very bottom. So these are the connection of the bus system. Let's see what here. Several devices. Data bus. The data bus is a bidirectional data or instruction codes from memory or input or output transferred into the microprocessor. The result of the operation or computation is sent out from the microprocessor to the memory or input and output. Depending on the particular microprocessor, the data bus can handle 8-bit or 16-bit data. The address bus is unidirectional. I don't know what I see. Or unidirectional, over which the microprocessor sends an address code to the memory or input to output. The size width of the address bus specifies the number of bits it can handle. The size of the width of the address bus is specified by the number of bits it can handle. The more bits there are, the address bus, the more memory locations the microprocessor can access. A 16-bit address bus is capable of addressing of 65,536 addresses. Control bus. The control bus is used by the microprocessor to send out or receive timing and control signals in order to coordinate and regulate its operation and communicate with the other devices, i.e. memory, or input and output. Microprocessor clock, also called clock rate, the speed at which microprocessor executes instructions. Every computer contains an internal clock that regulates the rate at which instructions are executed and synchronizes all the various computer components. The CPU requires a fixed number of clock ticks or clock cycles to execute its instruction. The faster the clock, the more instructions the CPU can execute per second. Clock speeds are expressed as megahertz or gigahertz. So microprocessors are super scalar, which means that they can execute more than one instruction per clock cycle. Like CPU's expansion buses also have clock speeds ideally. The CPU clock speed and the bus clock speed should be the same so that neither component slows down the other. In practice, the bus clock speed is often slower than the CPU clock speed, which creates a bottleneck. This is why new local buses such as AGP have been developed. So these are examples of a microprocessor, Intel 8085 and Intel 8086. So this is the microprocessor. The microprocessor, the 8086, is a bit microprocessor chip designed by the Intel, which gave rise to the 86 architecture. Development work on the 8086 design that started in the spring of 1976, and the chip was introduced to the market in the summer of 1978. In the Intel of 8088, released in 1979, was a slightly modified chip with external 8-bit data bus, allowing the use of cheaper and fewer supporting logic chip, and is notable as the processor used in the original IBM PC. Differences between those two processors. Sure, say micro. A microprocessor simply consists of the processor, that ALU, arithmetic logic unit, the instruction of the coder, and a few registers which are used to store data for mathematical and logical operations. Oh, 85, 8085 or 8086. Those are the microprocessor.
Coronavirus!
A microcontroller includes a processor, a unit of instruction, a decoder, a register, a encoded storage space, flash memory, ROM, RAM, general purpose input and output pins, timers, and interrupt controller, and serial communication module, etc. That is, the microcontroller is a microprocessor with some basic modules. So components of a microprocessor, or should we say microcontroller. CPU or central processing unit, input and output, bus, to the bus, RAM and memory, RAM and memory, RAM and ROM, timer, interrupt, serial port, and program port. So these are the general purpose microprocessor. So this is a diagram again, like I said earlier. Alright, this is the microprocessor. So, here again, microcontroller. Single chip computer, on chip RAM or ROM, or input output ports. Example, Motorola 6811, Intel's 8051, Xerox Z8, PIC 16X. So there's single chip microcomputer. So this is the diagram of a microcontroller. So these are the differences of microprocessor and microcontroller. So microprocessor, let's start from microprocessor. CPU is standalone, RAM and ROM, input and output, timer are separate design. Designer can decide on the amount of the ROM and RAM and I/O ports. Expensive, versatility, general purpose, high processing power, high power consumption. Instruction sets focus on processing intensive operations. Typical on 34 and 64 bit. Typically deep pipeline of between 5 to 20 stages. For the microcontroller, CPU, RAM, ROM, and input and output and timer are all on single chip. Fixed amount of on-chip ROM, RAM, and input-output ports. For applications in which cost, power, and space are critical, single-purpose, control-oriented. Low processing power, low power consumption, bit-level operations. Instruction sets focus on control and a bit-level operations, typically 8 to 16 bit. Typically single cycle, two-stage pipeline. Some popular microcontrollers, as you can see back now, microcontrollers are everywhere, even your digital watch, your phone, even for TVs, even for power strip, I don't know. So here are the popular microcontrollers: AB51 microchip technology PIC, Atmel AVR, and Texas Instrument, and MSQ430 16-bit. So that's for today. I hope you have a good day. Peace, y'all. I'm outie.